Let's make a triangle, right triangle, and ABC. This is B small, this A small, and this C small. And this angle C small. I will talk about angle A. So sine of A equals A to C. And you name it sine opposite to hypotenuse, mnemonic rule. Cosine of A is B to C. And cosine adjacent to hypotenuse. Tangent of A equals A to B. Cotangent A, B to A. And tangent is opposite to adjacent. And you studied Sokoto in school. I made an experiment in Moscow many years ago. We studied this stuff with third graders. Instead of Sokoto, I use mnemonic rule. I use different colors. For instance, sine, синяя, blue sky, hypotenuse. Cosine is juicy green grass, and you косить, mow the lawn. It was easy. Or tangent is, imagine tangerine tree. I'm always talking about numerator. Three go this way. Anyway, this is not difficult. In addition, we have secant A, which is 1 over cosine of A. And cosecant A is 1 over sine of A. You know this from school. I just review what we have. But later for SAT, you study how to use unit circle. Again, if you have any question, ask me. If you don't have any questions, let me make a unit circle. Imagine I have a unit circle. Circle where radius equals to 1. Somewhere like this. Because angle actually, not necessarily in reality, restricted by a 90 degrees triangle. Angle is rotation. Imagine this radius vector can rotate and make any number of revolutions, right? In real life. That's why for unit circle, if I make through the center Cartesian coordinates, approximately, and put from this center radius vector, and this angle, positive direction, is counterclockwise. This is theta, Greek letter theta. And I take different color. And from this point A, wherever, I will make perpendicular here. and perpendicular term. And you know that the radius equals to 1. By definition, this is unit circle. Okay. You can easily see this is X, this is Y. Let's say this is B, and this is O. You can see based on this relationship that OB equals OH times cosine of theta. Since OA, our radius equals to 1, you can write this equals to cosine of theta. So this is cosine of theta. If you look AB in the same manner, equal this radius OA times sine of theta. Since OA equals to 1, equals to sine of theta. And this is sine of theta. Sine of theta. So projection to x-axis is cosine. Projection to y-axis is sine. This is very important. One more thing. Since you know these angles are in triangle OAB, this angle and this angle complementary. This angle equals, and this is 90 degrees, 90 minus theta. You can get very important formula. Okay, pretend I'm here. I'm watching from this angle, this eye. And sine of 90 minus theta, if you're talking about this, equals opposite to hypotenuse, or OB from this perspective equals OH times sine, because it's opposite, sine of 90 minus theta. Or since OA equals to 1, equals to sine of 90 minus theta. For now, set up to this point, everything, students. I do easy stuff as well, because visualizing is very important. I need feedback. Samuel's, Theodore, feedback. Hands up. You're not listening, Theodore? Okay, Samuel M. But look at this. I get that OB equals to this. From another side, I found before that equals to cosine of theta. This is extremely important formula. It's related not only to sine, cosine, to, we name it, cofunctions. If we have sine, and this is key to so many SAT questions. To compare left and right part, they're supposed to have identical functions, sine and sine. Let's say if one side is sine, another cosine. Easy, you have a tool. If you take from 90 this angle, you get cosine of theta. And you can make two parts, we do it today many times, related to the same function. Keep in mind that any questions, right? When we're talking about cofunction, this works like this. Next fact you need. Angle supposed to be, this is, if you go counterclockwise, this is 0, this is 90 degrees, 180 degrees, this is 270, and this is 360, and so forth. Very often we use radians. You know what is radians, right? If you take radius of a circle and put around the circle and connect ending and beginning point, you get 1 radian. You know pi, 180 degrees, 180 degrees, this is key, is pi radians. 360 to pi radians. So you can, if during experience, you can easily use this like proportion, but I can write in radians. This is 0, this is pi over 2. It helps us a lot. This is pi, this is 3 pi over 2, and this is 2 pi, and so forth. So this is key to convert any angle to radian and vice versa. You also know this, right? One another fact, look at this triangle. Triangle OAB. Triangle OAB, right triangle. And from right triangle, you can write Pythagorean theorem. OB to the second plus AB to the second equals to OA to the second. But keeping in mind, OB equals cosine theta. So cosine square theta. AB equals to O, what is it, D, opposite sides of rectangle, equals to sine of theta plus sine square theta. And OA equals to 1. Equals to 1. So this very important formula, which helps you when you get sine, you can easily find cosine from this one. You name it Pythagorean identity. Okay. Who knows why you name it identity? What is identity? Just review. Who can tell me what is identity? I'll tell you. Identity is expression. It has left and right part, and always valid for any values of variables. Valid value, it always true for any valid values of variables. For instance, some example: 1 over 2 in parentheses a plus b equals 0.5 in parentheses a plus b. Whatever you put instead of a inside of a and b, you always get left equals to right. It is identity. So if you go in depth in trig, we have a lot of formulas in university. For SAT, you don't need a lot of formulas. We need just minimum, just very shallow stuff. But I show my diagram, which I usually use, to like mnemonic, right, for this one. Pretend I'll make a schematic and have this one. Pretend this is a circle. Not good. Then this circle, I split the circle by if I take radius and build this hexagon. And connect each vertex with the center. In this one, and nice, and this one. Then I will build it nice, okay? And I put this point, I put here tangent of x. This is sine of x. I start sine of x, after that move this way. Cosine of x, cotangent of x, cosecant of x, and secant of x. And look at this, how beautiful it works. How easy I will erase. I don't need this stuff. It's only for building. I don't need this one. If I take different color, and you see we have hexagon, we have 6 triangles, right? Let's say move inside of this. I put here in the center 1. I move inside of this triangle. What I'll get? How to memorize easily. Imagine you have this picture, you have sine of the second plus cosine of the second, cosine of x to the second equals to 1. The same, but easy. If I go to another one, for instance, this one. So difficult to memorize all this stuff. You can write. I start from this point. Tangent square of x plus 1. I go this way. Equals to secant of square x. You can easily check all of this. Or I'll let this is this one. I start from 1 plus cotangent of x equals cosecant, etc., etc. We have tons of identity. I don't want to spend time for this, but you get basic idea of what we need. Plus, you have a scientific calculator allowed only for section 4, but you have trig also in section 3. So you have to. Can I read this? Any questions about this stuff so far? I have many. If I had a few hours, I will give you tons of these identities. Easy to memorize. It goes from these pictures.
Dr. Farber, I don't completely understand the hexagon.
Hexagon. Okay. Do you understand this formula? Sine of square plus cosine is Pythagorean theorem from this one. Vanilla.
Yes, I understand.
Understand. Pretend you forget this formula. Pretend you forget this formula, because some people, kinesthetics, right, use images.
Yes.
If I tell you about lemon, juicy lemon, you don't see spelling of lemon. You see this picture, lemon, yellow, right? Nice color. Here I give some ideas. Or for instance, in 3rd grade, you study PEMDAS rule. Remember PEMDAS order operation? Please excuse my dear Aunt Sally, right? Parentheses, remember this, right? Yes or no?
Yes.
Or in physics, you study colors. Also some rules, or how to memorize 50 numbers of word pi. You have a poem. Each number of letters in each word give you 3, 1, 4, etc., etc. Every time people try to make their brain easy to work with. And in this particular case, this formula. Look at this. Forget what I wrote here. When I build this hexagon, I know these rules. If you take each of these to the 2nd power and go start from this point like this arrow, this is sine to the 2nd x plus cosine to the 2nd x equals to 1, because in the middle we have, in the center we have 1. This is the same formula, but easy to memorize. It's only for memorization.
Okay, I understand. Thank you.
This everybody knows, but what if I tell you, not everybody remember this one, but sometimes in your problem, sometimes you have tangent and secant. But look at this triangle. If we have tangent to the 2nd, I go this way. Plus 1 to the 2nd, I get secant to the 2nd instantly. No memorization. Isn't beautiful?
Yes.
So instead of memorizing, I have tons of this example. I just give you today minimum more. If you have course of trig, I will give you all this different stuff. Okay, let me read this. Any more questions, students?
Dr. Farber,
Yes,
could you move to the side so I could just copy it quickly?
sure. Tell me, can I erase something of this? Because I need more room for general observation. Raise your hand when you're ready to, when I can erase this. Waiting for you.
Dr. Farber,
Yes.
can you please explain the last Pythagorean identity, the 1 plus cotangent squared x?
This one? I will use
Yeah.
to be consistent. I use the same green. I get to this triangle, inside of this triangle. I start from here, 1 to the second. What is next? Pretend you're moving over there, right?
Mm-hmm.
From this point is 1 to the second plus cotangent to the second equals to what?
Cosecant.
To the seconds. This x.
Okay, thank you.
Welcome. We have more. If you're talking about identity, can I erase this? By the way, I show one more thing. Very beautiful. Think of this, which also helps. Pretend I have the same picture. The same. Okay. And what we're doing here right now? If you I use different color. It's for addition, now for multiplication. Look at this. I name it way of when two vectors meet each other. Let's say this one and this one. Okay. I make this like this, from this and this. And these arrows. I can write the tangent of x times cosine of x equals to sine of x. It works for any vertices. Or for instance, for this one, tangent of x times cosecant x equals to secant x. So if you two are on different edges and one in the middle, it's a result of product. Or you can make another vectors. For instance, I give example of this. Only example. If they move this direction, look at I use black arrow. It's also work for any pair. You can write the tangent of x multiplied by cotangent of x equals to what? 1. And you can easily see from this relationship, it's cotangent and tangent opposite. If you multiply this times this, it would be what? A over B times B over A. Cancel out equals to 1. So idea of this hexagon is great because all basic identities you can get from different varieties of direction of this vector. One more thing I want to mention. You get the idea, right? One more thing, which is very helpful for us. I give you a rule of fingers rule, I don't know. So let me erase it. Yes. So in SAT, let me create a table matrix. I can explain more, but I give just example. And this theta angle, and this is trig function. Trig function. Make some notes. And we have very specific angles you need to know. For instance, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And I put here some vertical lines. And we can use degrees and radians. For radians, I use different color. For instance, this one, green. This is in radians. It's pi over 6 is the same. Or pi over 4, or pi over 3, or pi over 2. And I have sine of theta, this function. And pretend, I don't know how to do this, let me put this way. I use a hand. I put hand. I don't know how to make this hand. Okay, this is hand. And I take different color. I take different color and put numeration for fingers. There is no finger here, 0. This is the first finger. This is the second. This is the third. This is fourth. This is fifth, etc. Okay. And pretend you forget about these values. I use formula square root of number of finger divided by 2. Look at this. for 0 degrees. Square root of 0 divided by 2 is 0. Agree, students? So sine of 0 equals to 0. If I illustrate the unit circle, and this theta is 0, its angle extremely small. And you see its projection to x-axis equals to 0. Now, when you have 30 degrees, okay, it would be square root of this is 30 related to 30 degrees, this related to 0 degrees, this related to 45 degrees, this 60 degrees, this is 90 degrees, and you can use the same, this pi over 6, pi over 4, pi over 3, and pi over 2. Okay, let's have one for 30 degrees. Square root of 1 divided by 2 is 1 over 2. 1 over 2. For 45 degrees, square root of 2 over 2. Square root of 2 over 2. For 60 degrees, this is for 45 degrees. This for 30 degrees. For 60 degrees, square root of 3 over 2. Square root of 3 over 2. And for 90 degrees, square root of 4 over 2, which is 2 over 2, which is 1. And this is 1. And you remember when 90 degrees, the theta approaching this y-axis, and projection would be 1. So this how you have to know this table, because in section 3 no calculator, how you can count if you have no idea how to count, or if you don't have these values, a calculator and so on. This you knew from the theorem. Remember the leg opposite of 30 degrees equal half of hypotenuse. And this is leg A to C is a sine. So in this proof, what about cosine of theta? Write this backward without thinking, like monkey. This is 1. This is square root of 3 over 2. This square root of 2 over 2. This 1 over 2 and 0. Beautiful. In one shot, you know cosine. What about tangent? Tangent of theta. Tangent of theta equals sine of theta. Remember, I erased this identity. Divide by cosine of theta. So take this, divide by this. For instance, for tangent of 0, this divide by this is 1, etc. Okay. And what about cotangent? Cotangent equals cosine of theta divided by sine of theta. My suggestion, you can finish this table by yourself. And good idea if you put in place where you have breakfast every day. And finally, you know this. Only don't forget one thing. For instance, whenever I count this one, tangent of, I give example 30, tangent of 30 equals sine of 30 divided by cosine of 30. And sine of 30 equals to 1 over 2. And you divide by square root of 3 over 2. Keep change flip, you have 1 over 2 times 2 over square root of 3. You get 1 over square root of 3. This is not nice. It is not normalized. Never ever have complex numbers and radicals in denominator. You have to normalize. How to normalize? Get rid of this denominator radicals. Square root of 3 times square root of 3. This and this. And you get square root of 3 over 3. And this is square root of 3 over 3. So just divide two of them. And don't forget, for instance, this you cannot divide. 1 divided by 0 is infinity. Put this one. Okay. This same divided by same is 1. Sine of 45, tangent of 45 is 1. Okay. And finally, if you divide this by this, keep chain flip, it will be square root of 3. What about cotangent? Okay. Cosine by sine. You cannot divide by 0. It does not exist. If you remember, graph of this is asymptotically goes to never intersect. Okay, but this one, you got it, right? Everything. 0 by 1 is what? 0. And this is also would be 1. And cosine and cotangent of 30 equals cosine of 30 divided by sine of 30. It would be square root of 3. Okay. So far so good. And finally, this you're supposed to divide this by this. It would be square root of 3 over 2, I believe. Square root of 3 over 3. Check it. But what I did here, what you're supposed to get only one line. On one line, I help you to use this hand rule. After that, just use definition. Cosine, it's shifted, put upside down, backward. Tangent is sine by cosine, and cotangent cosine by sine. You have this table. Good idea to know this table. It helps us a lot. So I can take more. If I need something more during explanation, I will give you. But for now, let me go through the question. Any questions of this, students? Any questions? No questions. Who understand up to this point everything? Raise hand.
I have a question.
Yes, please.
For a tangent of 30, why is it radical 3 over 3?
Just divide it. Let me check. Tangent of 30, check it. I said you're supposed to check it. Cosine of, you're talking about tangent of 30, right?
Mm-hmm.
Oh, I already did it. Okay, I already did it. What is sine of 30? 1 over 2?
Yes.
Sine of 30, square root of 3 over 2.
Mhm.
Keep, change, flip. 1 over 2 times 2 over square root of 3. So far, so good?
Yes.
Now, what I got here? I got 1 over square root of 3. So far, so good? Because I crossed it out. But we have to normalize. How we normalize? I take different color, and we can make, using equivalency, multiply numerator denominator by the same value. 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is square root of 9, which is 3. You must get rid of a radical in denominator. Okay, with normalization.
Okay, thank you.
So welcome. I don't think about too much this one. I need only know one line actually here. Next, if you have experience, you can do it automatically. More questions?
Dr. Farber, can you just quickly move to the left so I could copy it?
Absolutely. I teach trigonometry in depth for calculus, AP calculus, and many formula logarithm tricks. But behind the scene, my point, all in beautiful, very helpful, very helpful. Okay. Without trig, you can do anything in life at all. You use trigonometry every day, but you don't think about this. Okay. I give example. Okay, your parents commuting by cars, right? And they use GPS. How system figure out where's your location? Behind the scene trick, the method triangulations. Without this, forget about this. You will get lost in life every day. I use trig a lot in my research in robotics, etc. And behind the scene, very simple idea, like 1, 2, 3. Kirill, tell me when you finish.
Yes, I already finished.
Good. Many questions which you solve in geometry long way, you can do in one shot using trig. In one shot. It's not prohibited to use trig on SAT. If you know trig, your tools much richer, and you can solve SAT much faster. I give example to be more specific. Before to start, I give example. For instance, you have a triangle, geometrical equation, and this is 5, this is 7, and this is 30 degrees. And this is triangle ABC. And they ask you to find area. And if this angle is 30, what if 30 is from this table? You can find altitude, after that multiply base by this, etc. Right? But you can do in one shot, one line. Because area of triangle equals 1/2 A times B times sine of C. So plug in 1/2 5 times 7 sine of 30, which is 1/2. Many cases, another case, we have triangle, we have angles, let's say 30, 40, 45 degrees, and let's say this is 7, and they ask you to find this side, x. I will find this. Some reason you have to find the third side, etc. But in trig, you solve it in one shot, because you know x to sine of 30, even it's not right triangle, it's not right triangle, not right triangle, for any triangle, equals 7 to sine of 45. Sine 30, you know this 1/2, sine of 45, square root of 2/2. Everything is given in one shot, you find this. Isn't beautiful? One shot. So my point, trig, extremely important. Okay, let's go to this stuff. So I'm planning to open IT calculus. If you join this, you get much more information about this when I finish my project. Now let's go through this. I'm gonna go through most 3 class questions from trig. I believe this introduction was helpful for you. And you see general picture of mosaic. Let me start from extra, after that I come back to any of this question. Be ready to read it. From extra. Number 3. Okay. What is number 3? I make a circle. And this is the center. And this is 3 centimeters. And this is A, B, angle 5 pi over 6, the center angle. Okay. What the length of AB, well, the best way, again, I told you, most natural way to operate is not degrees. Degrees is very artificial. It was created ancient Babylonian about 7,000 years ago. Radians is more natural because radians related not voluntarily split the circle by 360 degrees. And in this, you have a formula S, length of arcs, length of equals R, theta. Why? Because what is theta? By definition, theta radians is ratio of length of arc to radius. This definition of angle in radians. From here, length of arc equals r theta. Everything is given. Equals 3 times 5 pi over 6. No problem. And which they provide in radians. Yes. Beautiful formula, use it. Any questions, students? You can do different, convert to degrees, after that make proportion, but why? It's one step. Again, if you have any question, ask me. Number 4. Number 4. In number 4, what the length of my, that's number 3. Which the following angles have the same trigonometric values at 450 degrees? Let me make a little bigger picture. Number 4, bigger picture. I have unit circle. Then it's Cartesian coordinate. Okay. Get the same as 450 degrees. Okay. What is 450? 450 degrees equals to 360 plus 90 degrees. And since by definition we start from this point A, and our radius vector rotates this way, it goes around, turn around. This is would be 360 degrees and plus 90, and point would be here in B. Everyone understand? So I make one revolution, which is 360, and plus 90. And this is theta, which is 90 degrees. And this theta is 450 degrees. But we get to the same point. And ask with the following angle have the same trigonometric values. Since this is the same angle, the answer is 90 degrees. Who understand? Why? Because we get to the same point. This is idea. Doesn't matter how many, you know that sine, cosine, etc. All these three functions, the periodic function. And period is 2k, 2p, 2 pi. 2 pi k is every time is repeating, right? It can be like million something degrees, but this is idea how many times it's repeating and what is remainder. 90. Make a sketch. If too fast ask me, it was number 4. Number 7. Again, I go through most request questions. Number 7. What we have a number 7? With the following seven. 1 minus cosine square x for any value of x. Well, just few minutes ago, I deleted Pythagorean identity. If you subtract cosine square x from both sides, cancel out, you get sine square x equals 1 minus cosine square x. So this equivalent to cosine square of x. Sorry, sine square x. Okay, one line problem. Okay, if you're too fast, ask me question. If too fast. To understand everything up to this point, students. Everything. Okay, let me expand a little bit here. Yes, if you have questions, put your hands down. After number 7, we have question for number 8. I don't ask you to read because this is one line here. Number 8. Y equals to cosine of x. We have a graph. And it looks like this. This is 1, this is -1. I refer to picture you have. When we for demonstration, I will make some, And this y equals to cosine of x. What's the question? What's the value of cosine 90 plus cosine 180? So this is f theta. Okay. And if you look at this picture, this is pi. You know what is pi? Is 180 degrees, right? This is pi over 2. What is pi over 2? Is 90 degrees. And the question is, what is cosine of 90 degrees plus cosine 180? From this graph, cosine of 90, when the angle is this 90 degrees, y equals to 0. This is 0. Because coordinate of this point is 90, 0. What about 180? Coordinate of this point is 180, -1. Because this is 1, this is -1. 0 plus -1 is -1. It's writing more than solving. It's also a few second questions, right, students? Any questions, students? Who understand up to this point everything? Hands up. I check how you're listening. Nicole B, Kirill, Ellison. Ellison, you with me? Wanna get red dot? Hands down, everybody. Be careful, Ellison. One more time, I check. You're not here. Bye-bye. Okay. 11. Okay. Let me make a number 11. The cosine of each of the following angles is not equal. Let me use a unit circle again. Move it. Good. So, and we have few options. 11. We have the cosine. We're talking about cosine of theta, of x, doesn't matter, is not equal to cosine of the other. We have a -120, b -60, c 120, and d 240. Okay. -120. What is negative? You have to go clockwise. So this is starting point 0. What is 120? Is -90 plus -30. I move this way, -90 and plus -30. So this so far -120. Okay. And this is H. You know, if I take different color, cosine, at the beginning of my lecture, I just demonstrated the cosine is projection to x-axis. And this would be cosine. Cosine of negative 120. I don't make it dirty here, but you get the idea, right? Next, we have this negative 120. What about positive 120? Positive 120 is 90 plus 30. You move this way, counterclockwise. This is 90. And this is D. Okay. You have, what is a D? Not C, C. This is C. I look into multiple choice. C. This 120. If you look at this for C and for A, we have absolutely the same projection. So it doesn't work because they ask you about negation. This means negation in F, right? Not equal. So cross out A, cross out C. What is left here? What about 240? 240 is, let's say, 360 minus 120. If you go from this point, this is 360 minus 120, you get to the same point. So this matching to D. Again, 360, you start from this point counterclockwise, make one circle, and after minus goes opposite direction, clockwise, negative at the same point. So D also does not work because the question about negation. Only answer is B, but let's demonstrate B. Why B does not work? If I take negative 60, it means I go clockwise, and this angle is over there. This is B, negative 60. And this is projection. If for all of them, result is negative, for point B, the result is positive. So that's why B is the answer. Maybe explain in very details, but I believe everyone understands 100%. Hands up, understand 100%. Ellison, Leah. Leah A. Ольга, свяжись, пожалуйста, с Эллисон. Ольга. Эллисон. С родителями свяжись. One more time, I kick you out from this program. Okay. Was in 11. The next is 13. 13. In 13, we have right triangle. Not to scale. And let's say ABC. And this right angle. This is 24. What is it, pi over 3? I believe yes, pi over 3. This is 24. For the area is square units of triangle. Pi of 3 is actually, we did today, it's 60 degrees. And this is 30 degrees. You can use trig and you can use theorem. The leg opposite of 30 degrees equal half of hypotenuse. And this is 12. Or you can use BC equals 24 times sine of 30. 24 times 1 over 2, which is 12. Okay. And now you can use the first way. Area of triangle equals 1 over 2 AB times sine of C. In our case, 1 over 2, 24 times 12 times sine of 60, or sine pi over 3. Sine of 60 is, you remember, is the same like square root of 3 over 2 in one line. Or you can use the second way. The second, AC equals 24 times cosine of 30. 24 times square root of 3 over 2. And now area base times height divided by 2, which is, after simplification, this is 12 square root of 3. Base height is 12. And divided by 2. Either way, it's a little bit fast. If you have any question, ask me. This easy question. Okay, all of them easy actually. There is no complicated ones. So far, so good. Who understand up to this point? Good. Hands down. 16. What we have in 16? Sine of x equals to cosine of pi over 6. Then which of the following could not be value of x? Not x. Negation, not x. And let me use multiple choice. A is, what is it, pi over 3. B is 2 pi over 3. C, 5 pi over 3. And D, 7 pi over 3. Okay, so far so good. So let's make a sketch for this problem. Remember, at the beginning of the lecture, I use cofunctions. Left and right part, they have different functions, but I have beautiful approach. For instance, sine of theta equals cosine of pi over 2 minus theta. This is the key thing. So you can use it, instead of this, I can write cosine here, cosine of pi over 2 minus x equals to cosine of pi over 6. Beautiful. Left and right part, we have the same function. If they equal, the arguments also equal, right? You can make assumption this and this equal to each other. I use beautiful property of cofunction. And pi over 2 minus x equals to pi over 6. Minus pi over 2 and minus pi over 2. Cross it out, negative x equals pi over 6 minus pi over 2. LCD is 6. This is 3, this is 1. It would be pi minus 3 pi over 6, which is negative 2 pi over 6, which is negative pi over 3. Okay. And this equals to negative x. And if I multiply both part by negative 1, I get x equals to pi over 3. So when pi x equals to pi over 3, they're supposed to be equal to each other. But pi over 3 is here, does not work because this is negation. Okay, so far so good, does not work. So it works, but we're supposed to get negation. What is 2 pi over 3? 2 pi over 3 is 2, and pi over 3 is 60 degrees, right? It's 2 times 60, which is 120 degrees. If I make a unit circle, I know this. Okay, pi over 3 is 60 degrees. So this is pi over 3. Degrees. 2 pi over 3, 120. What is 120? 120 is 90 plus 30. And 90 plus 30, 90 plus 30 is this one. And this is 2 pi over 3. This was A. And this would be B. But we're talking about sine function, sine of x. Sine of x is projection to y-axis. You see they have the same y coordinate, y projection does not work. Because they is looking for opposite. Okay, what is 7 pi over 3? Okay, you do the same way. Or 2 pi over 3, 1 by 1. Pi over 3 is 60. 5 times 60 is 300. What is 300? Remember, this is 270 and this is 360. If I start rotation counterclockwise, I get somewhere like this. This is 300 degrees. And projection for 300 degrees is negative. Not even the same value, but also opposite sign. That's why the answer is C. C as in cat. Just make a sketch. Any questions, students? Okay, no question. What 16? Next, students. Let me close this out. Pablo, how you understand this here?
I understand this question.
Pablo,
I understand. Good.
it was your question as well, right?
Yeah.
Number 20. 20. What we have in 20? Let me erase all this stuff. I leave this picture for you if you'd like. So far. What we have another 20. Given sine of theta equals to k, where 3 pi over 2 less than theta and less than 2 pi. If sine of beta equals to k, what the following could be value of b of beta. You have to find beta. And you have multiple choices. A, 2 pi minus theta. B, 3 pi minus theta. C, pi plus theta. And D, theta minus pi. Okay, let's go step by step. I use this space for sketching, right? To have more room. Let me put this already closer. Yes. Already closer. So make a unit circle. Maybe too big, but anyway. You know, this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. And you know this angle is in the first quadrant, right? Between this and this. And let's say this angle theta. Behind the scene, it's easy for you in degrees, is 270 degrees, and this is 360 degrees. In fourth quadrant, this is angle let's say what simple number for just for explanation. Let's say 300 degrees. Let's say only for explanation. So let theta equals to 300. You can feel it, right? Feel it. So what is 2 pi minus theta? 2 pi. It would be 360 minus 300, which is 60 degrees. And this angle is 60 degrees. Okay, let's say this is 60 degrees. And this is A. And sine of this B, sine of theta equals to K. So, this is my K. Because why? Sine of theta equals to k, and k is projection to y-axis. Yes, this is the beginning of lecture. Okay. What about b? 3 pi minus theta. 3 pi. 3 pi minus theta. 3 times 180 minus 300. 540 minus 300 is 240. And this angle is 240 degrees. This 180 plus 60. This is B. And this is 240 degrees. I use different color. $240. Okay. And this is KB. And this KA. Pi plus theta. What is pi plus theta? Is 180 plus 300, which is 480. What is 480? 480 is 360 plus 120. Always try to get 2 pi. 360 plus 120. Okay. So you start from this point, make rotation, and plus 120. And this would be what? My C. For C. I have the same C. KC. And finally, theta minus pi. Theta is 300 minus pi is 180, which is 120. It also goes to the same point. Why? Because it's 120 degrees. Okay. And they ask you which is not. You see KB, all this K is the same. What is K? K is sine of this angle. All of them positive. And you can say they equal if sine of 60 equals to square root of 3 over 2. And this is negative. So correct answer is B. Since negation. I could answer what I do, I usually check in the middle. But I decided to go one by one in order you really feel what you're doing. This is just sketching, easy, without thinking too much. Who understand up to this point? I step back. Everything. Try to extract this periodic function to pi or pi, whatever we have. It's 20. Next, many students ask 21. Let me find 21. Very close. What we have in 21? And 21, I make a picture. We have a circle. And this is 210, it's the center. This H, B, X, 7 pi over 6. This is 210. Reflex angle 210. Okay. Length of radius is 2. Don't forget, they give everything, you have to use it. You have to find x. Find value of x. Well, since you have radius, you can easily find circumference, step number 1. Circumference 2 pi r. 2 pi times 2, which is 4 pi. Since radius equals to 2. Easy. Okay. They give radians, they give degrees. You know this 4 pi, our circumference is 360 degrees, right? You can make proportion. 4 pi is 360. And 210, yeah, they say 210, this large part, AC. And 210 degrees, I don't know. Okay. When multiply x times 360, 4 pi times 210, divided by 360, cancel, cancel. Four goes into 36 9 times. You can simplify 21 and 9 by 3. It would be 3. This is 7. And you get 7 pi over 3. What is it? It's larger arc AB, AC, so this one. Larger. Because we have minor arcs. Okay. Now, this is 7 pi over 3. If you add them up, x length of AB plus 7 pi over 3 plus 7 pi over 6. It's supposed to be your entire circumference. Okay, 6 LCD 2 1. You have 6x plus 14 pi plus 7 pi, 21 pi over 6, or simplified by 3, it would be 7 pi over 2 equals to 4 pi. After that, if you subtract both parts, if you subtract from both parts, you don't need this one. It will be faster. Minus 7 pi over 2 and minus 7 pi over 2. Okay, bring down x, cancel out, equals 4 pi. I believe you don't see this right in this position. X equals to 4 pi minus 7 pi over 2. If you're not right, you get down. Easy question. Who understand this 100% up to this point? 100. Yeah, you use some applications, some browsers.
No,
If
I'm not using anything.
when you want. Now, let's go to the next one.
Dr. Farber,
Yes.
I have a question. So for part 2, you found the whole arc for
Yes.
AC.
Uh-huh.
And then why did you add it all and not just subtract by AB?
Look at this. If you look at this, pretend is like kind of necklaces, I don't know. These pieces, if I add this arc, plus this arc, plus this arc, I get entire circumference. I'm supposed to add them up. It's pieces
Okay.
of arc, all of them pieces of arc.
Okay, thank you.
Welcome. Okay. Next is, let me go to the next one. 25. Can I read this one? Or we need this? So can I raise? Yes, no.
Yes.
Yes.
With the following 25 equivalent. Tangent theta cosine square theta plus tangent theta sine square theta divided by sine of theta. If you look at this, you see commonalities, just factorize. I put tangent theta in parentheses cosine square plus sine square. The same argument theta divided by sine of theta. But this Pythagorean identity is equals to 1. Okay. And I have sine tangent theta divided by sine of theta. But remember at the beginning of lecture, tan of theta equals sine of theta divided by cosine of theta and divided by sine of theta. Sine of theta cancel out. 1 over cosine of theta equals secant theta. Which format they provided? Yeah, they provided the same format. Okay. Again, they don't use any extra what I give you. It's practically everything we covered. Next is 27. And 27. X equals negative cosine of what? 11 pi. What the value of x? Remember, we have cosine is periodic function, and period of this 2 pi, right? I want to find how many I represent. This is equals to what? Negative cosine of 2 pi times 5 plus pi. If you use a new unit circle, doesn't matter how many 2 times you're looking around, you get to the same point. But when you get pi, it goes counterclockwise to this point. And cosine is projection to x-axis. Cosine of pi equals to -1, right? I ask you which value of x. So if this is -1, and negative of -1 is 1. So far so good. If you have any questions, ask me. Okay. 29. In 29, we have a triangle, like make this same. ABC. This is beta. This altitude. This 13. This is 14.
Dr. Farber,
Yes.
I think you're going over 30, not 29.
I agree with you. Okay. Who need 30? Raise it. Put your hands down. Who need 30? Says I'm here. Put your hands down, everybody. Andrea, Daniela, David. And raise hand if you need 30. Who need 30, I explain. Okay, 30. Student asked 30 as well. Let me change order. This will be 30 after the 29. So what we have here, the area of triangle, area 240 square units of triangle, the slash triangle. Well, how to get area of triangle? Fourth grade. A times B over 2 or B times H. Sometimes base times height. In our case, is 40 times H over 2 equals to 40. And this is 20 after simplification. If you divide both part by 20, I'll get H equals to 12. So this is 12. And ask you to find what the tangent of beta. If this is 13, 12, this must be 5, Pythagorean triples. And tangent of beta, opposite to adjacent. This was 30. Now 29. If you have any question, ask me. Can you see theoretically many of these questions you can solve like in 40 seconds, right? Very easy. So trick for SAT is extremely easy. 29, what we have in 29? Oh, I see, yes, 29 is it. It's like this. Okay. And cross section of this cross section, they give this cross section over there. And this x, this is 36. And this is 24. In the 36, this must be symmetrical. This base angle the same, isosceles triangle, this 18 and 18. Okay. Okay. What is 24 is 4 times 6. 18 is 3 times 6. So this must be 5 times 6. So far, so good. Which is 30. Pythagorean triples. You know everything about this triangle. And cosine of x equals to b. Okay. What is cosine of x from this triangle? A, B, C. Cosine of x equals adjacent to hypotenuse. If I simplify by 6, it would be 3 over 5. If you have any question, ask me. So practically explain all 3 class questions. But if you still have any question, let me know, I explain. Kind of this one. And this is 4 centimeters, this distance. This is 8 centimeters. And this is 4 centimeters diameter. Okay. They ask you to find total volume. Okay. Well, if this is 4, radius 1 equals to 2. If this 8, radius this big one equals to 4. And volume of cylinder equals pi r squared times height. So volume, I would name it inner, these 2 pieces, inners. Volume inner cylinder. I mean these 2 small 2 pieces equals pi times 2 to the second, and height equals to 4. And don't forget to multiply by 2. Why? Because we have this and this part, front and back. Or 4 times 4, 16, 32 pi. Now, how to find volume large? Pi times 4 to the second. Did they provide this length? Yeah, this length equals to this is 14. This is 14. Since this 14, this one would be 14 minus 4 plus 4, because they stick here and here by 4. 14 minus 8 is 6 times 6. It would be 24 times 6, 144 pi. And they provide in terms of pi or what? Let me check. (16 times 6). I believe it's 96 pi. Yeah, 96. 16 times 6, 96 pi. And finally, what they ask you, find total. V total. Add this to this to this. If you add them up, you will get 128 pi. Since this is, if you plug in here 3.14, you get in decimals the results. Okay. Any questions about this? When you go to nice university engineering, you study a special discipline. We name it descriptive geometry. And you have a lot of fancy drawings in this. I have many books in descriptive geometry. But this is one of the easiest stuff, this one. Okay, look at this package where still you have difficulties. Tell me, I explain in this package. Because this was the most, some reason, questions. Okay, many students ask also number 11. 11 was this one, the last one. Paolo, could you read it please out loud, 11?
Sure. Okay, so a rectangular block with volume of 250 cubic inches is sliced into 2 cubes of equal volume. How much greater in square inches is the combined surface area of the 2 cubes than the surface area of the original rectangular block?
Okay, thank you. Nice reading. Number 11. Let's make a prism. Kind of this prism. And make it another. We have this prism. And they said volume of this prism equals to what? 250 cubic inches. And they cut it by 2 cubes. If you cut it by cube, okay, each cube has x, 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 x. Okay. And volume cube, small cube, equals to 50 divided by 2 because we have 2 cubes. This cube number 1, this cube number 2. Would be 125 cubic inches. On the other side, volume of small cube would be f to the third and equals 125 if you take cube root from both sides. X equals to 5. So we found this is 5 inches each. 5 inches. Now compare what they ask you to compare. They ask you to surface area. Area of 2 cube. Area of 2 small cubes equals area of one face is 5 times 5 multiplied by 6 faces and multiply by 2. Why? Because we have 2 cubes. What about area of prism? Equals, since this is 5, this side is 10. We have 10 times 5 and multiply by 4 because we have front, back, top, bottom, on 4 faces. Plus left and right, they have 5 times 5. Multiply by 2 because we have left and right faces. So this 50 times 4, 200. And this is 25, 50. Plus 50. 250 square inches. What about this one? 5 times 6, 30. 30 times 2, 60. 60 times 5, 300. And the question is, how much is bigger? Easy, delta H equals 300 minus 250 equals to 50. Okay, who understand this 100%? Okay, who has questions? If you have a question, remember I always telling you that whatever we're doing here is not SAT only, it's life. And many of these problems have a real application in our reality. Who will tell me how important this program and how we can use it? How people use this problem? Who can tell me? Any example? Don't tell me only to pass SAT test. I'm talking in real life. Who use product of this problem? I tell you, everybody in the world use this idea. Where is it? For instance, you eat nice bread, whatever, right? It's made of flour. How people make a flour? They take a grain and make powder of this, right? Or you live in building. To connect this brick together, you use concrete. Have you seen concrete? This is a powder. They take special substances and they crush it. And the more they crush, the smaller power, the bigger quality of your concrete. If they put brick on brick, after window blow, you don't have a house. It's like, remember this fairy tale about 3 piglets, right? 3 поросенка, how it's gone. So I can tell you about 20% of all energy in the world people spend to crush different materials. To get they get ore, to get iron, to get powder for this flour everywhere. Why they use it? If you crush even one time, surface area, which is criteria of activity of this powder, increasing. The more you crush, the bigger area you have. So I want to have a bridge between what we're doing here in reality. Because math everywhere around you. If people don't use it, okay, I don't know if our civilization will survive. Even primitive people who did not study SAT, they crush everything. They use special, I don't know, containers. They use stick, and they crush these different, grains. Intuitively, they knew it. The bigger surface, the more active your substance. All pharmacy will work on this, right? Believe it or not, everything. Pharmaceutical industry without crushing does not work. Well, students, that's about it. How you understand today's trigonometry? Raise your hand who feel beauty of trigonometry and you understand this. Okay. Who has David? You here, Diana? What I expect from you to do at home, redo everything. Try to review my these small introductions. Very helpful. I give you concise what you need definitions. And what else? I give you worksheets related to this trick. Try to do all the steps. Don't forget to send me your work with steps, nice steps. Answers supposed to go from your steps. Do the same steps like Dr. Farber doing. That's it. Any questions? If you don't have any questions, have a nice weekend. Be strong, be well. Enjoy math. Bye.
Goodbye, thank you.
Bye.
Bye, Dr. Harper. Have a nice week.
You
Thank you,
as well.
Dr. Farber. Have a good week.
You as well. Enjoy math, everybody.